What if Martians came to our planet? What if a Mars rover brought back some unknown organism that began to reproduce and wipe out all life on Earth? Well, we've seen this scenario hundreds of times in movies and read about it in books. But in reality, the situation is the opposite. We are the threat. Humans are the ones that could infect another planet. We are the ones that could become the destroyers of Mars. And to prevent that from happening, countries created an international agreement that forbids us from taking certain actions on our red neighbor in space. It sounds like science fiction, but it's real. This agreement is called the Outer Space Treaty. It was signed in 1967 by the Soviet Union, the United States, and the United Kingdom. The treaty states that no country that signs it can claim sovereignty over any celestial body. It also contains many other important rules, but one of them directly addresses how we should search for extraterrestrial life. Now, there's a possibility that certain regions on Mars could potentially host life. However, according to the Outer Space Treaty, exploring these so-called special regions is prohibited. That sounds strange, doesn't it? Searching for life on Mars is one of the main goals of the entire space industry. So, how can these areas be off-limits? Well, the reason is contamination. When we explore these regions, we might accidentally bring life there. A tiny but extremely resilient microbe or bacterium could hitch a ride on a spacecraft, land on Mars, and begin to reproduce. But scientists are not only afraid that Earth's bacteria will destroy Martian life, there's a possibility that these two types of bacteria will mix, and we will not be able to separate one from the other. But what if it occurs that these bacteria were originally from Earth? Imagine NASA spending billions of dollars collecting samples of Martian soil, where life has been detected. The spacecraft brings these samples back to Earth. Scientists analyze them and suddenly realize that these Martian bacteria are actually ours. They had arrived on Mars 10 years earlier, when a robotic rover was simply taking pictures of the Martian landscape. Here on Earth, we already know bacteria that can survive extreme pressure, incredibly low and high temperatures, and even the complete absence of oxygen. For such organisms, adapting to Mars conditions might not be that difficult. But what if they change in that environment? What if they mutate and take on new forms? Scientists might believe they've discovered true alien life, when in reality, it's just Earth microbes that evolved on Mars. There's also a chance that Martian microorganisms could mix with Earth bacteria, making it impossible to separate them. In short, exploring places where life might exist could create massive scientific confusion. And what if contaminating Mars with Earth's life causes it to spread rapidly? What forms would that life take under conditions completely different from Earth's? Mars and the Moon can be explored, but it must be done with extreme caution to avoid biological pollution. And don't worry, the Outer Space Treaty also requires us to be careful not to bring potentially harmful Martian life back to Earth. So, what exactly are these special regions on Mars? Well, they're places where conditions might allow microorganisms to survive, which are warm and wet spots. But here's the ironic part. We currently don't know locations on Mars that meet these criteria. But if there are such places, we can't reach them. So in practice, this law about special regions hasn't really been tested yet. However, scientists also talk about uncertain regions. These are areas that could potentially be classified as special regions after further study. One example is recurring slope lineae, or RSL. These are dark, narrow streaks that appear seasonally on Martian slopes. At first, scientists believed these streaks were signs of liquid water. Later studies showed that RSL are formed by dry granular flows. So, does that mean there's no chance of finding life on Mars anytime soon? Perhaps. But what about all those headlines claiming that water was found on Mars? Couldn't that mean life exists there? Yes, scientists have discovered water, and it's not just small amounts, but entire oceans. The problem is that this water is buried 7 to 12 miles beneath the Martian surface. For comparison, the deepest hole ever drilled on Earth, the Kola Super Deep borehole, is about 7.5 miles deep. We couldn't drill deeper on our own planet. Now imagine how much time, money, energy, and technology would be required to make a giant pit on Mars. For now, such a mission sounds more like sci-fi than reality. But let's say we do find a microbe on Mars and bring it back to Earth. What kind of danger could such a tiny organism pose? Well, science fiction thrillers give us dramatic answers, but there's also a real-world example. Take the fungus known as chytrid. This microscopic organism reduced populations of frogs, salamanders, and other amphibians across the globe. And this biological disaster affected humans as well. Chytrid is not an alien organism, but its story perfectly illustrates what can happen after even a small biological contamination. When chytrid infects a frog, it causes a severe disease. The fungus attacks the animal's skin, disrupting its ability to regulate water and electrolytes. Electrolytes are salts and minerals essential for biological functions. When this system breaks, it leads to heart failure. The frog doesn't survive, and the fungus continues to multiply and infect other creatures. The outbreak was first detected in northwestern Costa Rica in the early 1980s. From there, it spread south and east, reaching Panama in the 2000s. More recent research suggests that chytrid originated in East Asia and spread worldwide through the pet trade. How it evolved the ability to devastate amphibians is a story for another video. For now, let's focus on the consequences that still affect us even today. Over several decades, the chytrid epidemic caused massive declines in amphibian populations worldwide. Around 90 species disappeared entirely. The impact was especially severe in Costa Rica and Panama. As amphibian numbers dropped, so did the populations of predators that fed on frogs and salamanders. But that wasn't the main problem. Remember what frogs like to eat. They catch mosquitoes and various bugs. So after the fungus pandemic, the insect population increased dramatically. Now think about what is dangerous about mosquitoes. Yes, they bite and leave an itchy mark on your skin. But some species carry dangerous infections, such as malaria. As frog populations decreased, malaria cases among humans increased. Studies showed that infection rates began rising about a year after amphibian decline started. Over the next 3 years, the number of malaria cases rose, but then stabilized. About 8 years after the chytrid outbreak began, malaria rates started to decline and eventually returned to previous levels. Does that mean frog populations recovered? Unfortunately, no. Amphibians are still struggling. It's possible that humans simply took stronger preventative measures against malaria, or perhaps other animals began feeding on mosquitoes. Either way, the ecosystem never fully returned to its original balance. This is the core problem with biological contamination. Damaging one species disrupts an entire system. Like a chain reaction, problems spread from one link to the next. If a simple fungus managed to affect life on Earth where humans can fight epidemics, imagine what a microbe could do on Mars. Even if life exists there, a single Earth organism could wipe it out completely. The reverse is also true. A Martian microbe could cause serious problems on Earth. Imagine a spacecraft returning from Mars and landing in the ocean. A Martian microbe jumps into the water and attaches itself to a shark. The shark begins to change into something terrifying and starts attacking other sea creatures. Fish become more aggressive and begin attacking anything that moves in the water. Mars's bacteria is multiplying. The fish becomes unsuitable for food. Fishing industry suffers losses, and many people begin to experience hunger without fish. Marine mammals disappear, and things get worse and worse. Okay, let's not be so dramatic, but you get the idea. Now it seems there's new solid evidence that Mars once had rainforests, real rainfall, and long-lasting rivers. NASA's Perseverance rover found a mineral called kaolinite on the floor of Jezero crater. Down on Earth, this stuff only forms in warm, wet places with heavy rain that lasts for millions of years. And this kind of rain feeds jungles, not deserts. That means Mars had showers for a long time. And that changes everything we thought we knew about the planet. So that mysterious kaolinite doesn't form from a quick flood or a melting glacier. It forms when liquid water keeps soaking into rock over insanely long periods, breaking it down grain by grain. When Perseverance spotted kaolinite pebbles and boulders scattered across Mars, scientists realized Mars once behaved less like Antarctica and more like the Amazon. That tells us that ancient Mars had a stable climate, thick enough for atmosphere, and a functioning water cycle with clouds, rain, and runoff. The place where the kaolinite showed up, Jezero Crater, is pretty cool itself. It used to be a massive lake, fed by rivers that carved channels you can still see today from orbit. Scientists think those rivers could have washed the kaolinite into the crater like a conveyor belt of rainforest soil. Another theory is that a meteor impact blasted the material out of nearby terrain and dropped it there like cosmic shrapnel. Either way, water clearly moved these rocks around, and moving water is a huge deal because stagnant water doesn't shape landscapes like that. Every form of life we know depends on liquid water. Not ice, not vapor, liquid water that sticks around. A warm, wet Mars with rainfall would have had streams, wetlands, and chemical reactions happening non-stop, which are the same ingredients Earth used to kickstart life. Now, this doesn't mean Mars definitely had some creatures waving at the sky, but the planet checked way more boxes for habitability than we ever expected it to. For decades, Mars looked like a planet that maybe thawed for 5 minutes and then froze forever. Now it looks more like a world that stayed comfortable for hundreds of millions of years before everything went wrong. Scientists think Mars lost its atmosphere because it lacked a strong magnetic field, which is like a shield that protects planets from the solar wind, a constant blast of charged particles from the sun that can strip a planet bare over time. While all that rainforest talk grabs headlines, Mars keeps stacking surprises. In 2025, scientists spotted skylights on Mars. Those are giant holes in the surface of the red planet that drop straight down into underground cave systems, which formed long ago. On Earth, caves like this protect life from radiation, temperature swings, and surface chaos, which makes them perfect hiding spots if ancient Martian life ever existed. Some of these caves might be karstic, which means slightly acidic water slowly dissolved the rock, carving out underground chambers over time. That process needs liquid water and patience, which Mars apparently had plenty of back in the day. Scientists suspect these caves could trap ice, preserve chemical fingerprints of life, or even lock away organic material untouched for billions of years, like a time capsule no one has opened yet. The caves sit in a region called Hebrus Vallis, tucked between an old volcano and a massive plain in Mars's northern half. This area doesn't show signs of lava tubes, which scientists already know exist on Mars. Instead, it shows ancient river channels, hydrated minerals, and sediments that only form when water sticks around. Scientists spotted 8 skylights and knew they weren't impact craters because nothing splashed outward when they formed. The surface simply collapsed into empty space below. Researchers pulled this story together using old Mars mission data, including mineral maps, hydrogen readings that hinted at buried water, and ultra-sharp images from orbit. The big deal is this: caves protect things. They block radiation, trap ice, and preserve chemical traces far better than the surface ever could. If Mars ever hosted life, even tiny microbes, those caves rank among the best places to find what's left. Now, a year earlier, in July 2024, the Perseverance rover drove along what used to be a river billions of years old. After the river dried up, part of a rock face broke loose and fell into the channel. Perseverance found it sitting there, untouched for ages. Scientists named it Sheyava Falls. The rock's surface showed tiny dark spots scientists nicknamed poppy seeds, and larger pale blobs with dark rims called leopard spots. When Perseverance zoomed in, it also detected organic molecules. These are carbon-based compounds, the same basic ingredient every living thing on Earth uses. Scientists predicted years ago that if Mars ever hosted microbes, rocks like this one would exist. These spots matter because life needs energy. Some organisms use sunlight, others eat chemistry. Microbes can survive by moving electrons between chemicals, kind of like stealing spare batteries to power themselves. At Cheyava Falls, scientists think microbes could have taken electrons from organic compounds and handed them to iron in the rock. That reaction releases energy that microbes can use to survive. So, Sherlock, the evidence lines up. The dark dots and rims contain a mineral called vivinite, which only forms when iron gains electrons. When iron changes this way, it loses its rusty red color and turns pale. That explains why the centers of the leopard spots look lighter. Perseverance also found another mineral there called greigite. Greigite needs sulfide to form, and microbes can create sulfide by feeding electrons to sulfate, another chemical found in the rock. Now, scientists can't fully analyze this rock yet, but they already have one tool down on Earth, the kind so small you'd miss them unless you knew exactly how to look. If microbes ever lived in Mars's ancient oceans, they probably didn't leave skeletons or bones. They left chemical fingerprints locked inside minerals. On Earth, microbes showed up in oceans about 3.7 billion years ago, give or take. Mars had water around the same time. When water evaporates, it leaves minerals behind, and some of those minerals can trap microorganisms like bugs and amber. On Mars, scientists expect sulfate minerals to play that role. On Earth, gypsum does the same thing. To test this idea, researchers went to a gypsum quarry in Algeria. Millions of years ago, the Mediterranean Sea almost dried up and left thick gypsum layers behind. Those layers preserved ancient bacteria inside them. All this makes the site a perfect Mars stand-in. The team tested a compact device called LIMS, which is an easier way of saying laser ablation ionization mass spectrometer, which I'm only going to say once. A laser zaps a tiny spot on a rock, vaporizes it, and then reads the chemical elements released. Each element leaves a unique signal, like a barcode. That lets scientists spot chemical traces linked to life. When they aimed LIMS at the Algerian gypsum, scientists found thin, thread-like structures already known to be bacteria. They also spotted minerals that microbes help create, like dolomite and certain clays. That matters because microbes don't just leave fossils, they change rocks while they live. Mars makes this harder, though. Its environment differs from Earth's, and any fossils there would be billions of years old, not millions. Scientists also need to rule out non-living processes that could copy these signals. Now, lots of people think that to find all the answers, humans must go to Mars. And the number one goal for the first human mission to Mars is finding life, not digging up resources or setting flags. Scientists want to know if Mars ever hosted living organisms, if it still does today, or if the planet once ran the chemical experiments that led to life. After that, researchers want to understand where Mars keeps its water and carbon dioxide, how those cycles work, and how they changed over time. Geology comes next because rocks keep the planet's memory. Every layer tells part of Mars' story. Scientists need to understand how Mars affects the human body, the brain, and even group dynamics when people live together in isolation. Long-term plans go even farther. Scientists want to learn how plants, microbes, and animals survive on Mars, how radiation alters DNA, and whether reproduction works across generations. They also want to know if Martian microbes could harm astronauts or equipment.
On Mars, nothing is ordinary. That's why a single rock spotted by NASA's Perseverance rover in Jezero Crater has drawn everyone's attention. Its surface is covered with tiny spheres. This texture is both bizarre and weirdly, painfully familiar. Haven't we seen something similar on Earth? Yes, we have. Does it mean there's a mysterious connection between Earth and the Red Planet? NASA's Perseverance rover has been busy exploring Mars, and on August 5, 2025, it spotted something unusual. A rock that looks like it came straight out of a medieval armory. It looks like a knight's helmet forgotten after a battle. Or maybe it's the hat of a witch that crash-landed on the Red Planet. Researchers officially nicknamed the rock Horniflya. It has a dome-shaped top with a pointed tip and a rim that flares out. Its surface is rough and covered with tiny bumps. But the coolest thing is that the rock isn't just lumpy. It's made up almost entirely of little round spheres. Imagine bubble wrap that someone balled up and spray painted Mars red. Here you go. Geologists aren't too impressed by the rock's shape, but its composition makes them raise their eyebrows. Such little spheres could have formed in a few days. Chemical weathering, volcanic activity, or if rock vaporized by a meteorite cooled down and condensed. On Earth, rocks with similar textures sometimes come from processes involving water, and this is one of the reasons why everyone is so excited now. If underground waters had a hand in shaping the rock, it could mean there was a lot of water on Mars in the past. And water means life. Now, another cool thing about this helmet is that it's a floating rock. The term means that it looks completely different from those around it. Basically, this rock doesn't belong to the area where the rover found it. The best guess is that it was launched from another location. Maybe it was a volcanic eruption, or more likely, an asteroid smacked into the Martian surface and flung it across the landscape. Interestingly, this isn't the first bubble rock Perseverance has seen. Back in March 2025, it found another sphere-covered rock, and some of the tiny balls had holes in them. If you look closely at Horniflya, you can see a bunch of those too. That might mean they're what geologists call ooids, small spherical layered grains. On Earth, ooids form when calcium carbonate builds up layer by layer in shallow water. Picture a warm, shallow sea near the equator. The water is a little choppy and waves are constantly moving things around. That's the kind of place ooids are born. They grow like pearls in oysters. An ooid starts small, usually with a tiny grain of sand or some other speck. The water is overloaded with calcium carbonate, so every time the waves move that grain around, a new layer builds up. Over time, the layers pile on, and you've got yourself a neat little ball. Sometimes the center isn't as tough as the layers surrounding it. That's why the core can dissolve or even disappear completely, leaving behind a hole. If those Martian spheres formed in the same way, this might be the reason why they have those tiny cavities inside them. But there's another possibility. On Earth, the other way of ooid formation is biological. In other words, they sometimes start with the remains of tiny living organisms. Could the ooids on the red planet have formed in the same way? Of course. This doesn't mean we can slap a "Life Found on Mars" headline on it just yet. But the fact that these holes exist is a clue that hints that Mars might have had the right kind of conditions for life. Well, maybe not seashells and oysters, but definitely something worth paying attention to. Weird Earth-like formations aren't the only intriguing things found on Mars. In March 2025, NASA's Perseverance rover spotted something that looked like a bunch of tiny spider eggs. That something was made up of hundreds of little round balls stuck together. It was just sitting there on a hill called Witch Hazel, near the edge of Jezero crater. On closer inspection, it turned out to be a weirdly shaped rock with a bit of red Martian dust on it. Yeah, sadly, or luckily, those weren't Martian spider eggs. Even so, the formation really stood out from everything else around it. The Perseverance team named the weird rock St. Paul's Bay. It's a floating rock too, just like Horniflya. Something once moved this rock from its original spot. One theory claims that it could have been created when a meteorite smashed into Mars. The powerful impact must have blasted rocks into the air. Then, those bits could have cooled down and formed those tiny balls. If that's true, the rock might have come from really far away. Another cool find occurred in April 2023 when NASA's Curiosity rover took a little break from searching for signs of ancient water on Mars and stumbled upon a travel book. Later, scientists figured out that it wasn't really a book, just a rock, but it does look like a little hardcover with a page frozen mid-turn. This book rock is tiny, measuring only about 1 inch wide. In February 2022, the Curiosity rover spotted something that could only be described as a tiny flower made of minerals. It looked like little coral branches, but it was actually a mineral deposit, pretty rare to see in a flower-like shape. Most of these kinds of deposits form when ancient water mixes with rocks on the Martian surface, so they're not exactly new to scientists. But that one was unique, since it looked like a tiny plant or flower. In January 2023, the University of Arizona shared another bizarre image, a rock formation on Mars that looked like the face of a giant teddy bear. It had two distinct beady eyes, a button nose, and an upturned mouth. It was captured by NASA's Mars Reconnaissance Orbiter, which was orbiting the red planet at the time. Scientists from the University of Arizona explained that the teddy bear face was likely just a natural formation, like a broken up hill or mound in the center of an ancient crater. But let's get back to Horniflyer. Perseverance snapped that strange bumpy rock photo during its 234th week on Mars, and NASA even picked it as the rover's best shot of the week. Of course, the rover's main job isn't collecting cool-looking rocks. Perseverance was launched on July 30th, 2020 with a big goal: to search for traces of ancient microbial life and figure out if Mars was ever truly habitable. That mission is connected directly to NASA's Artemis program. It's focused on setting up a long-term base on the Moon. The idea is that such colonies on Earth's natural satellite will help manage and support the first astronaut landing on Mars. At the same time, SpaceX CEO Elon Musk has his own ideas. He wants to send uncrewed missions to Mars as soon as the end of 2026. In the meantime, Perseverance has been busy. Its first assignment was exploring Jezero Crater, a site chosen because it once held water. After 3 years of work, the rover wrapped up its full survey of the crater. It happened in December 2024. NASA explained why this mattered. If Mars really went through long wet periods, Jezero's lake beds or shorelines could be some of the best places to look for fossilized signs of past life. Perseverance isn't alone either. 4 other rovers have reached Mars over the years. The very first, Sojourner, landed in July 1997. Then came Opportunity, which was expected to last just 3 months, but ended up operating for an incredible 15 years, until 2018. As for the bubbly rocks, scientists want to know more than just what they're made of. They're curious about where those rocks originally formed, and whether they lie in layers that could reveal how different materials build up over time. Studying their unusual makeup could tell researchers a lot about Mars's inner processes and how its environment shaped the planet's surface over billions of years. And maybe we could finally find out if there was life on the red planet. Hey, you know what would be pretty cool? Having a tiny helicopter on Mars that can buzz around and scan the environment from above. Taking pictures and looking for hidden extraterrestrial life on its own. At some point, somebody at NASA said something like this behind closed doors. Then they went and actually did it. Say hello to Ginny, one of the most significant scientific achievements since we first started exploring space. Back in 2020, NASA's Jet Propulsion Laboratory, or JPL, packed a tiny side project onto the Mars mission. It was called Ingenuity, a flying experiment meant to test if powered flight was even possible on another planet. Just proof of concept, a test demo. The real mission was to explore the surface of Mars with the rover called Perseverance. In 2021, this 6-wheeled robotic scientist about the size of a small SUV landed on Mars in a place called Jezero Crater. Scientists believe there was once a lake here about 3.5 billion years ago. That's important because where there's ancient water, there might have been ancient extraterrestrial life. Perseverance is basically a science lab on wheels. It can study rocks, drill into the surface, and stash samples in little sealed tubes for later. These samples are part of a long-term plan. NASA and ESA plan to bring them back to Earth in 2033 for more study. This could finally answer, has life ever existed outside Earth? Maybe samples won't give the definitive answer, but it's our best shot. Suddenly 2033 seems very far away. The rover has other instruments and testing tools that could greatly benefit future exploration of Mars. But the hero of this story is Ginny. They got the idea for this little chopper from drones here on Earth and thought it could fly around and scout for Perseverance. However, actually making it work on Mars sounds almost impossible. The first problem was the atmosphere. Mars has approximately only 1% of Earth's air pressure, which means there's barely anything to push against. On Earth, chopper blades bite into thick air to generate lift. Since there's basically no air on Mars, it's sort of like trying to swim in fog instead of water. Then there's gravity. Sure, it's only about 38% of Earth's, which helps a bit, but not nearly enough to offset the lack of air. To fly at all, the device would have to be feather light, with huge blades spinning like crazy, just to grab onto the thin air. Oh, and there's also the cold. At night, temperatures plunge to -130 degrees Fahrenheit, which is approximately the same as the coldest night ever recorded in Antarctica. That's enough to damage most electronics, and batteries hate the cold. So Ginny charged up during the day with a tiny solar panel, then used that power to keep warm through the freezing Martian night. Every day, scientists had to hope that their drone worth $80 million wouldn't land under a hill in a shadow, especially since it couldn't be controlled manually. Mars is so far away that signals can take up to 20 minutes to get there. Imagine playing a video game where your character has that kind of delay after you press a button. Ginny had to be fully autonomous. All these technological technicalities, and yet Ginny did not simply fly. What was first planned as a 30-day test trial with 5 flights ended up being a full-fledged support mission that lasted 3 years. So, how did engineers pull it off? First, they had to make Ginny as light as physically possible. Only 4 pounds. That's lighter than my house cat, but somehow it still carried 2 cameras, a battery, a flight computer, a radio antenna, and even a heater. Everything had to be trimmed down or miniaturized. Then came the blades, Ginny's most important feature. On Earth, a small helicopter spins its blades between 400 and 500 RPM. But we explained why that wouldn't work on Mars. So, Ginny's 2 rotor blades had to spin 5 times faster, about 2,500 revolutions per minute. Each blade was about 2 feet long, made from carbon fiber. Light as a feather, but tough as nails. And instead of sitting side by side like on a drone, those blades were stacked on top of each other, spinning in opposite directions. That cancels out the twisting force you'd normally get from a single spinning blade. You know how helicopters have that tiny tail rotor in the back? They need that because when their main rotor on top spins to lift the chopper up, it also creates a twisting force called torque. That makes the entire vehicle want to spin in the opposite direction. Without some way to fight that, you'd end up doing donuts in the sky. However, Ginny couldn't have a tail rotor because it would add too much weight, take more power, and make things even more complicated. So, engineers created a workaround with 2 large blades stacked on top of each other, spinning in opposite directions, which prevented the drone from spinning out of control. As for controlling it, Ginny didn't have a full-blown AI, but it wasn't remote-controlled either. NASA uploaded flight plans from Earth, but once the drone took off, it flew itself using onboard sensors and code. Basically, like a really smart autopilot. To stay on course, it watched the ground with a downward-facing camera, kind of like tracking its own shadow as a guide. And finally, the result was seen in April 2021, when Ginny lifted off the Martian ground and hovered in place for just 39 seconds. It rose about 10 feet into the air, hovered a bit, spun around a little, and landed safely back on the red dirt. It was short and simple. One small step for a drone, but a huge one for humanity. For the next 3 years, the team responsible was testing the limits, flying Ginny further and further. From above, Ginny saw more than the rover could. The drone helped map the terrain, spotted risks like loose sand and sharp rocks, and even found shortcuts for Perseverance. It even saved the rover, so to speak, when its photos helped the team reroute the vehicle around a tricky dune. Ginny also made snapshots of interesting layered rocks, exactly the kind you'd need when you're searching for ancient life. Basically, once the drone spotted something weird or promising from above, Perseverance would roll over to check it out. And it worked way better than anyone expected. However, in January 2024, Ginny went missing. The drone was supposed to do a short hop, go up, hover, land, easy stuff. But after takeoff, NASA lost contact. For a while, no one knew what had happened, just silence. A few days later, NASA finally got a weak signal and pulled the flight data. Turns out, Ginny flew over a featureless terrain. See, it used its downward-facing camera to track movement, kind of like an optical mouse. No texture below meant nothing to lock onto. Mid-flight, the drone got disoriented, tilted, and during landing, one of its blades clipped the ground. NASA confirmed it. The rotor was damaged. It will never fly again. However, this is not a sad story. Even with broken wings, the robot is still useful. After Flight 72, NASA gave Ginny new software and a new job, staying powered on and quietly collecting daily data, possibly for the next 20 years. In a way, Ginny has gone from scout to ground-based observer. So, what happens next? Well, we wait for 2030 while we make more flying robots. The biggest one on the horizon is Dragonfly, a car-sized rotorcraft scheduled to launch in 2028 and land on Titan, one of Saturn's moons. Titan has a thick atmosphere and low gravity, a dream environment for a flying drone. Dragonfly will hop from one location to another, searching for life in that icy landscape. It's like Ginny's big cousin, but with nuclear power and a whole moon to explore. The Project Ingenuity's success is already inspiring NASA to design better Martian helicopters. Some of them could be equipped with grippers to pick up rock samples, or even join up with rovers for full-on search and collect operations. Thanks to Ginny, what started as a tech demo could one day evolve into a fleet of flying robots crisscrossing the red planet. If you're scared of spiders, never ever visit Mars. In March 2025, NASA's Perseverance rover found something looking like a bunch of tiny spider eggs on the surface of the red planet. This something is made up of hundreds of little round balls stuck together. What if all these eggs hatch? Will hordes of eight-legged creatures swarm the red planet? Doubtful. The thing found by Perseverance was just sitting there on a hill called Witch Hazel, near the edge of Jezero crater. On closer inspection, it turned out to be a weirdly shaped rock with a bit of Martian dust on it. Yeah, sadly, or luckily, those weren't Martian spider eggs. Even so, the formation really stood out from everything else around it. The Perseverance team named the weird rock St. Paul's Bay. It's what scientists call a float rock. This term means that it didn't form where it was found, but somehow got moved there. So, at the moment, we don't have enough clues to figure out its background and how it got that strange texture. But that's not the only mystery. Something had to move this rock from its original spot. One theory claims that the rock could have been created when a meteorite smashed into Mars. The powerful impact must have blasted rocks into the air, and those bits could have cooled down and formed the tiny balls we see now. If that's true, this rock might have come from really far away, and it could give us new info on how big impacts move stuff around on the red planet. NASA thinks the rock might have just rolled down Witch Hazel Hill. It could have come from one of the darker layers up on the hill. We have seen those layers from space. Now, the goal is to study Witch Hazel Hill more closely and find out if those layers are made of the same stuff as the St. Paul's Bay rock. If so, it might mean a few things. Maybe there was volcanic activity in that region, or a big meteor hit, or there might have been groundwater there in the past. If this theory turns out to be true, there's a chance that some of those rocks might hold tiny fossils from ancient microbes. That's why NASA is planning to bring some of the rocks back to Earth in the 2030s with the Mars Sample Return mission. We'll get to study them up close and maybe, just maybe, find signs of ancient Martian life. Now, the funniest thing about it all is that it isn't the first time scientists have dealt with arachnids on Mars. Spiders on Mars is actually the nickname for a weird-looking surface feature. In certain places on Mars, you can see big dark cracks that spread out like spider legs. Some are huge, over 3,000 feet wide. From above, they seriously look like a bunch of creepy crawlers moving across the planet. These spooky shapes were first spotted by Mars orbiters in 2003, and they've been showing up in satellite photos ever since. At first, no one had a clue what they were, but now, scientists think they form when carbon dioxide ice, dry ice, sitting on the surface, suddenly turns straight into gas. That fast change causes gas to shoot through the ice and carve out all those strange crackly patterns. An even cooler thing is that NASA scientists have been able to recreate those Mars spiders in the lab here on Earth. They built a special setup mimicking Mars's surface and watched tiny versions of the spiders form right in front of their eyes. The team had been trying to recreate those Mars spiders for 5 years. When it finally happened, they were overjoyed. Back in 2021, scientists managed to explain how those spider-like marks form on Mars using something called the Kiefer model. The basic idea is that in spring, sunlight shines through big, clear chunks of frozen carbon dioxide, aka dry ice. That heats the Martian ground underneath, and the ice starts turning straight into gas. The gas builds up under the ice, and when the pressure gets too intense, boom, the ice cracks. Gas shoots out, dragging dark sand and dust with it, leaving behind those spooky spider patterns once the ice melts in summer. The team tested this theory using a big special chamber nicknamed Dusty. Yeah, that's a real name. It's about the size of a barrel and can recreate the freezing cold, super low pressure conditions on Mars. We're talking about -301 degrees Fahrenheit. The researchers also put fake Martian soil in the chamber and covered it with CO2 ice. Then they used a lamp underneath the soil to heat it up, just like the sun heats up Mars. Their experiments worked, and little spider shapes formed just like they do on the red planet. The study also revealed something new. The team found that ice formed inside the ground too, and it caused the soil to crack along with the ice. This might explain why the spider's legs are so zigzagged instead of straight, like we might expect. Next, they want to keep doing experiments to figure out more about the Martian spiders, like why they only show up in some places on Mars and why they aren't getting more common over time. The red planet is apparently set on playing tricks on people from Earth. For example, in April 2023, NASA's Curiosity rover took a little break from searching for signs of ancient water on Mars and stumbled upon something curious: a travel book. Later, scientists realized that it wasn't really a book, just a rock. But it does look like a little hardcover with a page frozen mid-turn. This book rock is tiny, measuring only about 1 inch wide. So it might not hold any ancient Martian stories, but at least it's travel size. Then in January 2023, the University of Arizona shared another bizarre image: a rock formation that looked like the face of a giant teddy bear. It had 2 distinct beady eyes, a button nose, and an upturned mouth. It was captured by NASA's Mars Reconnaissance Orbiter, which was orbiting the red planet at the time. Scientists from the University of Arizona explained that the teddy bear face was likely just a natural formation. like a broken-up hill or mound in the center of an ancient crater. Another cool find occurred in February 2022. The Curiosity rover spotted something that could only be described as a tiny flower made of minerals. It looks like little coral branches, but it's actually a mineral deposit, which is pretty rare to see in a flower-like shape. Most of these kinds of deposits are formed when ancient water mixes with rocks on the Martian surface, so they're not exactly new to scientists. But this one is unique, since it looks like a tiny plant or flower. Now, the next discovery is even wilder. Once, the Curiosity rover snapped a pic of what looked like a perfect doorway in a Martian cliff. Naturally, people started wondering if it was some kind of secret entrance or maybe a hidden base for astronauts. But in reality, it's just a really cool rock formation. Winds and erosion carved away at the rock over time, creating a perfect symmetrical shape. Going even deeper into the past, back in 2018, a researcher noticed weird stick-like shapes in an image and thought they looked like fossilized animal footprints. Unfortunately, NASA quickly shot down the idea. Those tracks turned out to be salt deposits that formed in areas where water evaporated. You can find something similar on Earth too, for example, in dry lake beds. So, while it's pretty interesting that there's more proof that Mars used to have rivers and lakes, these tracks aren't evidence of life, just a quirky rock formation. Now, the next find is absolutely amazing. NASA's Opportunity rover found round, blueberry-like rocks on Mars back in 2004. But those aren't the kind you eat with your cereal. The blueberries you're looking at are made of iron, and they're evidence that Mars used to have a lot of water. Over billions of years, water smoothed them out and created these little balls. Scientists think that they formed when Mars was much wetter than it is now. The iron-rich blueberries are a pretty big deal because they show that Mars could have been a very different place a long time ago.
And we have liftoff of Mars Global Surveyor as America begins its journey back to the Red Planet.
There's a weird structure on Mars, a square, a near-perfect square standing alone in the endless red desert. And it looks too perfect, too precise to be anything but artificial. Nature's chaotic, and it rarely makes things look so deliberate. So the internet took one look at it and lost its mind, as the internet tends to do. The image spread like a virus on social media, igniting every conspiracy theory you can think of. Some were convinced it was proof that intelligent life had once tread upon the Martian sands. Well, let's dive in and sort it out. The image is real, and it's really old. The thing, not the picture. NASA's Mars Orbiter camera snapped it in 2001, capturing a tiny slice of Martian terrain, and there sat the square. Now, is that evidence for intelligent life? Well, Mars is an empty world now, a rust-colored desert. But once, long ago, it may have been something else entirely. A planet filled with roaring rivers, vast oceans, and thick clouds rolling across the sky. Now, in a world like that, life, if it ever had a chance, could have taken root. And there's a possibility it did. Scientists think that life could have existed on Mars in a short period from around 4.1 to 3 billion years ago. It could have started during the early era of Martian history, called the Noachian period, and lasted all the way to the late Hesperian period. Meanwhile, here on Earth, the first oceans were just forming. Life on our planet was just beginning, in the form of tiny bacteria in deep-sea hydrothermal vents. While Mars was already fully wet, on Earth, there were no plants or animals, just microscopic life trying to survive. So, Mars took the lead in the life game. It had a much thicker atmosphere, which could have trapped enough heat to keep water liquid. Valley networks, huge traces across the red landscape, show us the incredible story of rainfall, rivers, and lakes. Huge asteroids were still hitting Mars at the time, and they could have brought organic molecules with them. But if that's true, What happened, and where did life go? A recent NASA study suggests that the answer is more complicated than we thought. Astronomers believe that something drastic happened to Mars, like boom, and its cozy climate was gone, its atmosphere thinned. Without a strong magnetic field like Earth's to protect it, solar radiation stripped away the air, leaving Mars cold and dry. The ocean simply evaporated. Some of the water escaped into space while the rest froze underground or became locked in polar ice caps. Today, all that remains is a ghostly memory, dry channels and salty mineral deposits. But it looks like the transition wasn't sudden at all. It was slow and gradual. The planet was changing from wet and warm to cold and dry over millions of years. In fact, Mars kept its ocean even after the temperatures dropped to freezing. Some parts of Mars, especially the northern lowlands, might have remained wet for many, many centuries. Shouldn't the water freeze when it gets below 32 degrees Fahrenheit? Well, yeah. But there are many reasons why this miracle happened, like Mars's thick atmosphere and warm water traveling through currents. And during that time we mentioned before, from Noachian to the late Hesperian, life could have found a way. Microbes on Earth thrive in some of the harshest places, beneath Antarctic ice, in deep sea vents, in toxic volcanic lakes. Hey, life doesn't care. So these times in Martian history would be amazing for it. But don't be mistaken, Mars was never a paradise. Even during its cozy times, it wasn't as lush and green as we might imagine. In its early days, Mars was something more extreme, something closer to the young Earth. During the Noachian period, it was warm yet wet. Then the climate shifted into the Hesperian period. Oceans were stretching across the northern lowlands. Temperatures dropped, and snow piled high, forming massive glaciers in the south, transforming the planet into an icy world. Finding microscopic life at that time is possible, but an intelligent civilization? That's less likely. The square that went viral isn't evidence for intelligent life yet, and here's why. First things first, people freak out because nature doesn't make straight lines. But that's not really true. Actually, nature does it all the time. For example, here on Earth, we have the Giant's Causeway in Northern Ireland, a beautiful field of hexagonal basalt columns. These are completely natural. They're formed by volcanic activity. There's also the Devil's Tower in Wyoming. Hey, remember it from the Close Encounters movie in the 80s? That's a symmetrical rock formation, and it was created by erosion. However, if we looked at these things from space, they'd look artificial. So, what is the square? How about a fracture pattern in the rock or some terrain that's broken apart along straight lines due to stress? This happens on Earth all the time when rock expands and contracts over time. And on Mars, the surface is just constantly battered by meteors, winds, and extreme temperature shifts. No wonder rock would get stressed. What happens here is another case of pareidolia. It's our brain's favorite thing, to spot patterns in something random. Hey, we evolved like this. So sometimes we might look at natural objects and see insane stuff. Faces on trees, animals in clouds, shapes, and so on. Besides, NASA has been photographing Mars for decades. We have high-resolution images of craters, mountains, valleys, riverbeds, everything. Wouldn't an ancient civilization leave us, well, something better than some square-like rock? Even though things erode over time, we'd find more signs, roads, foundations, artifacts, ruins, or at least something. Though, to be fair, we do see something. The square wouldn't be the first time Mars has played tricks on us. Over the years, we've spotted everything, from tunnels to carved faces, even Bigfoot. Or this doorway, for example, a perfectly cut rectangular opening. That's what people saw when NASA's Curiosity rover sent back an image of the East Cliffs on Mount Sharp. It's almost like an ancient passage leading deep into the surface. You just need to go in and find some fantastic underground base. Well, NASA decided to take a closer look at it. It turns out it's just 12 inches tall and 16 inches wide, the size of a dog door. That's because what we're looking at isn't a doorway, but an open fracture, a break in the rock that happens naturally over time. These kinds of cracks are extremely common, both on Earth and on Mars. They form when bedrock is stressed, expands, contracts, or gets eroded by wind and time. If you walk through a desert here on Earth, you'd see plenty of similar shapes. Canyons, cliffs, and even boulders have fractures that, from the right angle, might look like doorways. They're just not getting photographed by NASA. Also, the straightness of lines turns out to be just a trick of perspective. If you zoom out, you'll see that it's just one small break in a much bigger rock formation. Or the infamous Cydonia face. The photo was taken back in 1976 by NASA's Viking 1 orbiter when it was scanning Mars. In the region known as Cydonia, it captured what looked like a massive humanoid face, a rocky formation about 1.2 miles long. And this one face inspired books, documentaries, movies, and podcasts. But when NASA's Viking orbiters first took pictures of Cydonia, the cameras weren't super advanced. The image of the face had a low resolution and made the details fuzzy. NASA's later missions had far better cameras, and when Mars Global Surveyor revisited Cydonia in 2001, the truth was undeniable. The face was just a hill, a lumpy rock formation with ridges and depressions carved by wind and erosion. And in 2006, during another mission, a colored image with insanely high detail was made. No traces of face left there whatsoever. That's another pareidolia trick for you. Now, Mars has plenty of secrets left to uncover, but they will be related to its fascinating history, not some secret ancient civilization. The conclusion is, don't trust everything you see online. Sometimes a mysterious rock is just a rock. NASA made this cool rover called Curiosity and sent it to Mars to see what else we can find out about the red planet, the one that will possibly become our next home. Curiosity has been exploring the surface of Mars, taking measurements and gathering data about the planet for more than 10 years. And good old Curiosity stumbled upon some interesting wave-rippled rocks in the region of the Martian surface that was kind of expected to be drier. Scientists believe this area was actually a lake bed. It might be the bottom of a dried-up lake and all that sediment and other things that have accumulated there. All this can give us some important clues about the history of the lake. For instance, the types of organisms that might have lived there, how deep the lake was, how long it was there, and similar stuff. These wave-rippled patterns tell us that these rocks may have formed when strong Martian winds were moving the water in this big ancient lake. You know that specific sound you can hear when you're holding a seashell to your ear? You actually hear it because of the way the air gets trapped inside the shell and moves against its walls. The air cannot escape, so it vibrates at frequencies that depend on the size of the shell. In other words, you have a feeling you hear the sound of waves hitting a shore. That's Mars in my imagination now, a spot where you can still hear the long-lost sound of waves crashing against the shores of mysterious gigantic lakes. During its mission, Curiosity also came across a metallic object which turned out to be a meteorite. This unusual rock that came from space is made of nickel and iron. Its name is Cacao, and it's about the size of a small car, 6.5 feet long, and weighs over a ton. This is an important discovery because we don't often find metallic objects on the Martian surface. Most of the rocks there are made of basalt or some other volcanic materials, so that chunk of metal could tell us more about the history of Mars and how it formed. Plus, it definitely stands out. The surface of Mars is red from oxides, while Cacao is metallic-looking and dark gray. It's rounded and smooth, too, which means it once passed through Mars's atmosphere. There have been other robots exploring Mars, too. For instance, NASA's Mars Reconnaissance Orbiter, MRO, stumbled upon circular sand dunes. Sand dunes are usually very common on the red planet. They come in many different shapes and sizes, but circular ones like these are really rare. They consist of dark sand with light-colored material surrounding them. And the cool thing is that these dunes are arranged in a specific pattern, similar to the spokes of a wheel. It could be because of the way the winds blow. But back to our buddy, Curiosity. It's been exploring many other interesting things, like oxygen levels in the Martian atmosphere. The levels change depending on the season. There's more oxygen in the spring and summer. It's still not clear why, though, and of course, even that is not enough for us to really breathe there. The concentration of oxygen on Mars is 0.1%, which is about 100 times less than the concentration in Earth's atmosphere. The atmosphere of Mars is mostly made up of carbon dioxide, with traces of other gases. Curiosity was so good that it also decided to analyze the age of rocks it found. It seems they're much older than we previously thought. Some of them date back more than 3 billion years. Curiosity found organic molecules in soil samples too. These molecules are basically building blocks of life. Now, this doesn't prove there's indeed life on Mars. It's just one of the things that suggests there might have been some form of life a long time ago. Curiosity discovered potential evidence that there might be a large reservoir of liquid water beneath the south polar ice cap, probably very salty and full of different minerals. This high salinity is the reason why this water could remain liquid at temperatures well below freezing. It would be cool to have some sort of subsurface ocean to take a dip in, especially when these crazy Martian winds are raging on the surface. And it would be great to have something that would protect us from those insane radiation levels on the red planet. There are some pretty toxic chemicals and salts in the Martian soil, which can be really bad for humans. Astronauts could potentially end up being exposed to these toxic chemicals, either through direct contact with the soil or by inhaling dust that contains these salts. Also, these substances could be a problem for growing crops. This is a really big discovery for long-term missions to Mars, because astronauts would need to be able to grow their own food so they can survive while there. Another thing that favors the idea of potential life on Mars is discovering methane there. Methane is a very important finding because usually living organisms produce this gas. So, where did it come from if not from them? In reality, there are a few possible explanations for that. One is the geological activity of underground reservoirs. Another idea is that meteorites brought methane to the red planet. What's interesting is that levels of methane are higher in particular areas. So, yeah, I don't know about you, but I'll stick to the theory that it comes from living organisms. Now, it's possible that volcanoes on Mars are still active. We know there are many extinct volcanoes on the red planet, but we've never found enough evidence to prove that some of them are still alive. Scientists studied volcanic deposits and found out that some volcanoes could have erupted maybe 50,000 years ago. Before that, everyone thought the last eruption happened 3 to 4 billion years ago. If you could compress the geological history of Mars into just one day, this would be like having an eruption a second ago. So, you never know. There might still be magma bubbling in secret under the Martian surface. All the future generations that might end up building their life there could really have some fun. Mars turned into a cold and barren place that can't really support life over time. And one of the main reasons for that was losing its atmosphere. The red planet used to have a much thicker atmosphere, similar to Earth's. One major reason for that is its relatively weak magnetic field. Earth's magnetic field helps protect our atmosphere from the solar wind, a stream of charged particles that comes from the sun. Without this protection, Mars had nothing to help it confront this insanely strong force that eventually took away most of its atmosphere. Another factor that played a big role in the loss of Mars's atmosphere is its relatively low gravity. Because Mars has weaker gravity than Earth, it's easier for gas molecules to escape into space. So Mars probably used to be more similar to our home planet. But with its current thin atmosphere, it can't keep any heat, which makes it very cold and very complicated for us to explore. But maybe it's better for us that we didn't visit the red planet back in its old times. There's this story about an ancient mega-flood that might have happened there. So yes, the red planet probably used to be a wetter and more hospitable place than it is today, with beautiful flowing rivers and amazing lakes, ponds, and other bodies of water. And some research showed evidence of large channels carved into the planet's surface. These channels are way bigger than any we previously found on the planet. They suggest this mega-flood happened billions of years ago. Perhaps it happened as a result of different factors, like volcanic activity, melting ice, and the release of carbon dioxide from the planet's crust. The flood may have created some temporary pools of water too. Hopefully, it will mean more interesting clues for finding traces of microbial life. How about that?